Welcome to this particular video. In this video, what we're basically going to look at is actually that of the random forest, you can say random forest regression and that of random forest classifier. So these two guys are basically part of that of the assemble method. When I mean by assemble method, when I mean by this of the assemble method, this assemble method are basically ways that you can actually make use of that of the multiple tree-based decision to actually make decision. We have actually encountered one of the tree-based of making decision by building multiple tree like this of the decision tree that we have here. This decision tree actually makes use of it builds that of the tree, and it asks question by each as like each node asks a question. Maybe each node answer maybe it's true or false. You move on to ask different questions like we actually saw. So when it comes to this of the you can say the random forest builds multiple trees. And I mean build multiple. That's one thing you should know about that of the assemble method of I can say model that make use of assemble method. And when we look at all these boosting classifiers, I can say boosting algorithms out there, they also make use of this of assemble method. This is the one of this advantage of this of a assemble method is that multiple trees are being built, and these multiple trees, depending on the algorithm that of the model actually use, like some algorithms outside there, I can say some model when they build multiple trees, so they actually align each of the trees. Maybe some built it in parallel, some actually built it in maybe in can say sequentially. So maybe some of them are actually maybe average all of them to actually make prediction. Also, I can say the best that have the best accuracy, they actually make use of it to actually build. I can say they actually make use of that one that actually has the best, or the tree that actually have the best accuracy to actually give you the output. Or wise one, those ones that are built sequentially, actually the next tree, the first tree is going to learn from the data, and the next tree is going to learn from that of the mistake of the next data. So, but as we go on, we're still going to encounter some of all these, I can say all these assemble method out there. So the first one we're going to encounter is this of the random forest. This random forest is really powerful model in the world of machine learning. So what this random forest actually was, he built his trees in parallel, meaning that when he builds his trees in parallel, the output is going to be the mode, the tree that actually perform really well. So let's actually say that y is actually that of the maybe each of the tree. Let's assume this is each of the tree. So the way it actually works is that let's assume that let's assume that this is yi, and then the actual y that is going to actually give you is going to be the mode. Do you know what mode is? Like your medium mode. The mode is going to be the highest. So it's going to be that of this of the, let's assume that this is y1. Remember that this is actually yi. So let's assume this is our y2 to maybe to something like to that of the y. Remember that this actually signifies this of the tree. So the tree that has that of the best and say best performance is actually being picked. So this is how this of the random forest actually works. So if you are still getting it confused, you can check my video on that of the decision tree, so you can actually get the ideology. But one thing you should know that decision tree actually build one tree. Once you the model actually build one tree, that is not actually part of the assemble method. Assemble method builds multiple trees. So you can get these two guys actually confusing, or can get it complicated on your head. So this is actually most of the time this is actually that of the classification on this of the random forest classifier actual work. But when it comes to that of the regression program, so let's say this is going to be our y, the output, and then how it works is make use of that of the average of all the, I can say all the models. So this is going to be, assuming that this is 1 over t, this signifies the tree or the tree that is present. So it's going to be this of the y1, can say y2, the same thing, and then this of the yn. So let's assume when we look at it, you can actually set the number of trees that if you want to actually build, and how far is going to actually ask question within those trees. So the more tree it builds, can make the model more robust, and the more robust it be, can take time to actually finalize and learn everything. I know at times as it's learning, if the tree is actually too much, as it's learning, you can actually get even confused on itself. So actually, basically, what to actually handle this, we are going to make use of that of the parameter tuning, but we're not going to go into that of the parameter tuning. I just want us to actually make use of it, understand it, and then we can actually when we get to the section of parameter tuning, so we can actually make use of parameter tuning to actually see how we can actually set our own parameter. Because setting parameters without making use of the default parameter, you need to actually know what you actually do, not just be setting random parameters on the go. So this is for the regression. There's my cursor. This is for the regression. This is the formula that regression. Remember that this is the number of observation of the tree, which is this of the t here is number of observation of the tree. Let's assume we have like 10 trees here, so it's going to be 10 is going to be definitely be down here. So each of them is going to be divided by that of the number. So it just basically the simplest way I can explain this random forest that we're basically going to use. Remember that I want key thing you should know it belongs to that of the Ensemble method, and it builds multiple tree. So once it builds multiple tree, definitely is going to be more powerful compared to this of decision tree. The math behind this random forest it might not be really complicated compared to some other model like that of the k nearest neighbor and some other models that don't actually even perform well there, but their math is more complicated. But this random forest, the math behind the random forest is actually really complicated. But in case if you're interested in learning the full math, you can go online to actually browse it online to actually check random forest math. It's just combination of multiple maths to actually make one. Can say multiple other sections to actually make one particular equation, like how we saw in our linear regression where we solved it, where we just assume where we have our y equals to mx plus c. M have its own formula and our c has its own formula. Just more like say multiple equation to make up one. So but you can actually check online to actually grab all these guys. So to actually make use of this random forest, remember that I said that this random forest belongs to that of the Ensemble method. So first of all, I need to actually say from our, let me do this, we're going to say from our this of our Sklearn the what Ensemble. Yeah, this is Ensemble. Want to import, what do we want to actually import? We need to import our, so this should be RandomForestClassifier, and then we need to actually import that our, so what have I done? So can say our what RandomForestRegressor. So we are going to make use of these two models. So the application is just basically this, and there's not really much different. You can actually make your prediction. You can actually start by this is our classification that we actually have here. So we can then move on to that of the regressor, make use of that of the regressor. So therefore, remember in our previous video, we're able to make use of this support vector. Can say support vector classifier. So we are going to make use of this random forest classifier. Simple as that, just change it. So this is our data. So I've explained this data over and over. I'm even getting tired at times. So this will just turn it to pandas data frame, and then the input feature that we're going to actually set was this is salary and year experience. Remember that this is actually dummy data, but in a real life scenario, data is going to be more broad than this. Another thing you should know that you need to actually pre-process your data really well, and which I've actually taught really well in one of my previous videos. So you can actually learn how to process your data by making use of encoding, by making use of data handlers, handling NaN values, using some features, removing noises. There are just thousands of ways you can actually handle your data before you can actually turn it to a pandas data frame, pick the features you want. After you're done picking the features you want, then you can actually make use of the train test split. I explained this train test split really well one of my previous videos, so you can actually just check it out in case if you feel interested. So this is actually trying to control the amount of value, you can say amount of rows or data that is going to be used for training, because the main ideology behind this test size, because you make use of setting that of the test size, you can actually use it to control the amount of data that is going to be used for this of the training. Setting test size to be 0.2 signify that is 20% of your data you are going to be used for testing, and then the remaining 80% is going to be used for training. Remember that training data must be at least far greater than that of the testing. Remember that testing data, the model have never seen that of the testing data, so you are going to actually testing data is to know how well the model actually performs. That's just basically ideology of the testing data, to know how well the model is going to perform in the future before you can actually give it out. Because if you don't know how well the model actually perform when you're actually doing that or development, so it's going to be a problem when you send it out for public to actually use. It's going to be a really huge problem. So it's actually a good idea because of this test, so you can actually know how well the model actually is going to, how well the model is actually going to perform. So we fitted it on more on the data, or more of the data, that's 80% of the data. Remember that you can actually control this. Let's has been 170 to be used for the training, so you can actually set this to be 30. So once 30 is being used for testing, automatically 70 is going to remain. So it's going to be used for the training. So we predicted that of the S test, so we can actually check that of the accuracy score. Remember that most of the time accuracy score is not enough, because accuracy score just try to show you on those of the all the corrected prediction over the total prediction, like the one that they predicted correctly divided by total prediction. That's what basically what accuracy score is, just targeting how well was able to predict correctly. So, but we can also look at this confusion matrix and classification report. This actually give you more insight, and is actually one of the other key things to actually look at when you actually trying to know how well the model actually performed. So okay, we are going to make use of this random forest to actually classify this data, actually predict this data. Remember that our age, salary, and our year experience is our target. Sorry, is our features. How do I say target? Our features, and our target is this of the data here. Remember that I said this is actually small data. I just want us to make use of dummy data. As you can see, small amount of data. Let's now try and make things more complex. So our years, the features is going to be our X. I can say the input feature is going to be our X, and the target is going to be our Y. And remember that what our target is what we're actually trying to predict. So let's actually look at how well the random forest was able to classify. When we look at the random forest accuracy score, is actually that of the 33%. But when we look at that of the our other classifier we have actually been used, like this of the support vector, k-nearest neighbor. Most of them were actually at least they're reaching at least accuracy of 66%. But even though random forest was powerful enough, but I also wonder why it was able to predict 33%. Maybe it didn't find much pattern within our data. Random forest is actually really powerful when it comes to scenario that I say some scenario that there are more data, so it's definitely going to outperform these other guys that will actually encounter. I have used random forest really well, and in real life scenario, random forest is far more superior compared to all these other models I've actually ever encountered up to this point. But other models are really powerful on their own, but as we go on, the more model we are going to encounter is going to be more superior compared to the other one. No model is actually superior to the other one, just that their predictive power and the maths, actually the logic behind them is more advanced compared to the previous one. So this actually makes, when we look at this of our accuracy score, like how we saw earlier, we got 33%. This is the okay, let me zoom this up. So this was it. This is our our data that we actually have, which we actually saw earlier, and this is what the prediction that actually made. And this is our accuracy score 33.33, and this is our confusion matrix. This is actually true positive, true negative, false positive, and then false negative. So he predicted only true positive one. So out of all this guy that he predicted only one correctly, because when we look at this 33.33 times 3 is definitely going to give you, that should be 100 or so. That should be 100%. So each prediction he made had that of if you predicted 1 correctly, it's going to be 33.3. So he predicted only 1 correctly. When we look at this, true positive was only 1. So he predicted two positive, but out of that positive he predicted 1 was actually correct. And this is actually false positive. Yeah, he predicted one positive, but that one he predicted that was positive was actually negative. So that actually makes sense. And this is the false positive. So this guy predicted this guy to be 0, but meanwhile the result supposed to be 1. So this actually settles it. Precision, you can actually look at the precision, the record, and the F1 score, the support. So this actually explains a whole lot of things. So we can actually look at, remember, if you want to make your custom prediction, let's actually look at how you can make custom prediction, like how let's say you want to predict your own. So you can make a 2-dimensional, I can say two list here. So we know we first parameter we have what we're actually sending is that of the values of that of the features. You don't know the target. So let's assume we have the age to be 2. Let's say because age is the first, salary, let's say earning maybe 34,000. Yeah, this is actually 34. This is actually 34,000, maybe, and the year experience you have is maybe 34. This is actually maybe in the company you are 2 years old, and then the salary you are making is 34,000, and the year experience you gather before you enter that of the company is actually that of the 34. So we are going to see what the model actually is going to give us. So we are going to silence this, what is it called, this of our accuracy score, because this applies this to that of the testing data. This is actually our custom prediction. So let's actually look at this. Let's actually create a variable so it will be easier for us to actually know what to actually do. So this is going to be predicted result. So this is going to have predicted result. Yep, this is predicted result. So we can actually know that this is actually what was being predicted. So let's actually run this. I remember another thing you should know that. So let's also go for that of the regression that we actually have here on top here. So we're going to we have the regression data already, and we have actually selected. Remember that this data we have actually been using all this way up to this particular particular point. So don't think we have actually changed anything. So we selected our features, the X, which is our input features. We make use of that of the iLog rather than that of this make use of the names. You can actually make use of the name, can make use of the iLog. The advantage of this iLog, make use of this iLog, is that in a situation whereby your input features are much, I can say your column names are really much. So instead of writing, let's say I do have like 20 columns, or maybe you have like 50 columns, and then you can actually manually come and write all these guys, all of them out. It can be really hard. So the best thing you can do is to actually maybe the target, you can actually move it to the. I've explained how you can actually rearrange your data. You can actually rearrange it. The target will be the last, so you can actually just directly make use of this iLog. So just to make things easier for you. And then the y, we set the y to be this of the target, which is the last element, by making use of this -1. This -1 is taken. If you have actually watched my video on list, which is we're talking about that of the indexing method, this is not actually going to be anywhere problem for you. So make use of this S-train, our S-test. That's basically what we use. S-train, S-test. The actual split our data, like I explained, are just basically the same thing. So model is going to be this of our that should be RandomForestRegressor, because this is actually regressor problem. This is actually 31, 36,000, 38,000. We look at the regression problem. Our data, our target was actually that of the discrete value that we actually have here. This is actually going to be 0. So this is going to be 1, 0, 1, 0, 1, 1. And a whole lot of them. So when we look at this, or when we made our custom prediction, this is actually predicted result. So the predicted result was actually 0. So this signifies that okay, this actually belongs to that of the 0. You can say the target is going to be that of the 0. So it all depends on what you're actually trying to predict in general. So this actually classifies this. In case you want to make custom prediction, the same ideology applies to this of the regression. So let's actually comment this out. So the same ideology actually implies it to both of them. So I can actually just comment these guys out, so things will make things more complicated. So this is it. I actually commented it out. So remember that when it comes to this regression, the way you can actually know how well the regression is actually performing is make use of, it's not like how we actually make use in that of the how we actually does it in that of the regression, that I can actually put out of the accuracy score. No, it doesn't work like that in regression programs. So I can say make use of that of the regressor. So what it can actually do is that of the mean square error, mean average error, and this of the R2 square. When this mean average error, mean square error, the lower the value, the better how well the model was actually being and how well the model is actually performing. So the same thing, train test split controlled by this of the 0.2, which is at 20% for testing. The model have never seen this 20%, and the random still set it to 42. The model will make use of this random forest regressor, and we fitted it on this our S train. Our S train comprises of our 80% of our data. Yeah, that's actually basically it. So let's assume you have 10 rows of data. 80% is basically going to be 8 rows, and the 20 is going to be for testing, because we set the test size to be that of the 0.2. So hope this actually this actually explains it really well. So this mean square error, we are getting almost 148. This is actually 1, 2, 3. This is actually like more like 14 million, and then we are getting 2000. The model is actually, the regressor actually perform a little bit better compared to that of the classification that we're actually having. Okay, can look at it was able to classify almost 95% of the variation within our data, because what we have 0.94 here, we actually 0.7, which is actually more like 95% of how well the model is actually perform. This actually makes sense when we look at it. So remember that the reason, because the target tends to have more relationship to that of the input feature. So this is actually the simplest way to actually make use of this random forest regressor. I remember that the reason why we're able to just implement these guys was because of Sklearn. Actually, if you try solving this random forest regressor by yourself, it's actually it can actually be tiring. I can actually take you a longer time compared to this. So the best thing you can actually do is actually on your free time, you can actually look online for. I'm going to drop a link where you can actually get the formula. I think the formula, I solved something on it. Solve the formula that I'm going to paste the script on my GitHub link. So my GitHub link is also being in the description down below. So in case if you're interested, you can actually just see how you can actually solve this random forest regressor manually. You can see some of all these models, not just random forest, some of all these models manually. You can also see the graph. I can still see the chart in case if you're actually interested on it. So we actually covered for random forest regressor and random forest classifier for classification problem, which is actually for that of the discrete, and for classification regression is actually for continuous values. When I mean continuous, I mean nothing that tend to be increasing, or it's not actually just a discrete value. Remember that if you can actually, it's not actually a bad thing if you make use of regression for classification and classification for regression, but they are not actually built for that. Because if I put classification here, I can say classifier regression, random forest classifier here, I bet you that it's definitely going to perform almost like about 90%, because when we look at this of our target actually tend to increases as the age and salary and the years experience actually increases. So was able to actually is going to learn really well this of the data, but this is not actually for classification data, but it doesn't actually signify that it doesn't actually it won't actually hurt if you actually maybe make use of that of the regression classifier on that. If you see that, if you find out that your regressor is actually performing really poorly, you can actually maybe test maybe on that of the make use of classifier to actually test whether classifier is going to perform better than that, because no one thing about classifier actually give you that of the exact results. That's one problem about classifier. Let's assume this is if it was actually classifier that you actually use, this is actually 71,000. Classifier is going to basically just give you, maybe I predicted maybe 72,000, it's going to give you 72,000, but when it comes to this of the regression, it's going to give you 70, maybe 72 point something, or maybe 70 point something. Even though it's not exactly able to predict it correctly, it's going to continue give you continuous values rather than the discrete value that this classifier actually gives. So this just basically the two ideology behind this classification and regression. I've explained these guys many times, so this is actually more than enough to explain it. So as we go on, we're still going to look at all these ensemble methods. So in the next video, what we're basically going to look at is that those of the boosting classifier. We're going to dive into more of boosting classifier, more into these ensemble methods that we'll actually be looking at that of the gradient boosting classifier, either boosting classifier, and after that we're going to dive into that of unsupervised learning in Python, because everything we'll be doing is actually called supervised learning, so don't get it confused, supervised and unsupervised. When it comes to supervised, we have targets. When it comes to unsupervised, we don't have target. Target does not exist anywhere. That's just the two ideology there. So I think I'll be happy to see you in that next video. Thank you for watching.